Simple determining algorithm. It is a determining algorithm for frequent item set mining. Means it can identify data items that have frequent occurrence with each other. So to start with apriori algorithm, we will first see how we can use this algorithm. So a priori algorithm can be used in several places in daily life also. A shopkeeper can use this. For example, if he maintains a database of which item are bought and by which customer, then he can find that which items are bought together from his shop. So in this way, if a database contains the items which are used together generally together, then we can find the which are frequently used together items. It can be used in text processing also. If the words are stored as an item in the database and the text context is stored in such that which words occurred with which word, then we can find that which are the frequently occurred together words. In such way, a priori algorithm can be used in image processing, spoken word speech processing also, to find the image pairs or spoken word pairs. So now we will see our example. So consider a vegetable shop database. The shopkeeper have carrot, beans, capsicum, chili and salt. So we will consider only a small period of time and with small number of items for this shopkeeper. In a short period of time, the database is created. In a short time duration, the database maintains the information for a short term duration. So in that short term, customer 1 bought carrot, beans, capsicum, chili and salt. Customer 2 bought carrot, beans and chili, and like this customer 7 bought beans, chili and salt. So now from this table we can make a table like this, that carrot has been bought 5 times, beans have been bought 8 times, capsicum 6 times, chili 7 times and salt 4 times. So we can see that how many times each of the items have been bought. So in a priori algorithm there is a threshold value. Threshold value determines up to which the value will be considered as a frequent item or not. Means consider the here we take the threshold 4. So the items have been bought 4 times or more will be treated as frequent items. So here we will singly every item is a frequent item. So now we will consider the pairs. So in this case we can make the pairs carrot beans, carrot capsicum, carrot chili, carrot salt, beans capsicum, beans chili, beans salt. So and we noticed how many times each of the pairs occur in the table. Now we will discard the non-frequent words which is less than the threshold value 4. So this will be discard carrot and salt 2 times, beans and salt 3 times, capsicum salt 2 times and chili salt 3 times. So this will be done for the pairs. Now we will consider the triplets. So in triplets we can omit the non-frequent pairs automatically, as the non-frequent pair cannot be included in a triplet which will get more value more than the threshold value. So if we consider the pairs which are non-frequent, then this will be the table. So we can ignore this table without calculating the values. We omit this table only from the pairs table which are non-frequent, which if the pair is a non-frequent one, then we will omit this pair from the triplet. So now, omitting those triplets, we find the triplets carrot, beans, capsicum 4 times, carrot, beans, chili 3 times, carrot, capsicum, chili 3 times, and beans, capsicum, chili 4 times. So now we have to ignore those which are less than the threshold value 3. So now we will discard this. After that, we will consider the quadruplets. In quadruplets also, we can omit the triplet which have less value than the threshold value. So here we can make only one quadruplets, but it also contains the triplets having less than the threshold value, so we can discard these quadruplets. Now finally we have the pairs. These are the final pairs, and these two are the final triplets we can consider as a frequent set. So this is very simple. We can use it anywhere. It has some drawbacks also. A priori algorithm has some drawbacks also, as it is a very simple algorithm. The time and space complexity of this algorithm is very high. Also, the second problem is the database need to scan many times, and for this there will be a problem for big databases, as the database should be static until the entire algorithm finishes, because for each of the steps, for the new table, the algorithm will scan for the first table and the last table, the previous table, to find the new table. So this will be problem, and the main problem is that there will be a pre-specified threshold to start. Before starting the algorithm, we have to fix the threshold value. The threshold value will be the measure of the frequent or not for each item, so we have to fix it before the algorithm starts. So I think you all understand the a priori algorithm. So if you have problem, let me know. Thank you.